Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at part 2 of our Semester 1 midterm review. Let's go ahead and get started. In problem 1, we have the Sears Tower in Chicago is 1454 feet tall. How far away on the ground would someone have to be to create an angle of elevation of 61 degrees? Let's go ahead and draw a model for our problem. So here's my Sears Tower, and let me do a better job than that. Right, there's my Sears Tower, and somewhere over here on the ground is some person creating an angle of elevation of 61 degrees by looking up to the top of the Sears Tower. Again, we know 1,454 feet tall, and we're trying to find how far away on the ground that person is, which would be this distance x. So notice that relative to the 61 degrees, 1,454 is the opposite. What we're looking for, x, is the adjacent. So we're going to go ahead and set up the tangent of 61 degrees is equal to 1,454 divided by x. We now know in the next step we're going to multiply x on both sides, so we would get x tangent of 61 degrees equals 1,454, and then we would divide both sides by tangent of 61 degrees, which would give us that x equals 1454 divided by tangent of 61. Make sure that your calculator is in degrees, since the angle we are working with is in degrees. And after you plug that into a calculator and calculate, you would get that that distance is approximately 805.97 feet. Remember that the problem asks us to round to 2 decimal places, so we round to 805.97. There we go, good enough. All right. In problem 2, we want to convert 16 pi over 9 radians to degrees. Well, keep in mind, and this is coming from the notes, that 1 radian is 180 degrees over pi. So if I have 16 pi over 9 radians, we're going to multiply that by 180 degrees over pi. Notice here, the pi's will cancel. 180 degrees, or 180 and 9 can reduce with each other. So 180 over 9 is 20, so we get 16 times 20, which is 320 degrees. In problem 3, we want to find which angle below is not a coterminal angle for 75 degrees. Well, as we saw in part 1 of our midterm review, if we are working in radians, we want to add and subtract 2 pi as many times as necessary to generate coterminal angles. In this problem, we're working in degrees, so we need to add and subtract 360 degrees as many times as necessary to generate a list of coterminal angles. So let's start by adding 360 degrees. If I take 75 degrees, let me pull out my calculator here. If I take 75 degrees and start adding 360 to it, well, plus 360, that's going to give me 435 degrees. So that is one of my coterminal angles. Notice in the instructions we're looking for the angle that is not coterminal. So I'm going to go ahead and cross out A, because A is coterminal. Let's add 360 degrees again. This would give us 795. So 795 degrees is another coterminal angle. Well, we're looking for the one that's not coterminal, so we'll cross that out. Notice that in my answer choices, the remaining answer choices are negative, so I know I can go ahead and stop adding 360. Let's go back to the original angle of 75 degrees, and let's start subtracting 360. All right, so 75 degrees minus 360, that's negative 285. That's a coterminal angle. And let's go ahead and subtract 360 one more time. We get negative 645 degrees. So notice that our last answer choice here, it says negative 655. Negative 645 is the next coterminal angle. So this is not a coterminal angle. In problem number 4, we want to select all the following statements that are true. Okay, true. And all of these statements are actually going to come directly from our unit circle, so have your unit circle ready. Statement A says tangent is undefined at both 0 and pi. Well, looking at my unit circle, and notice that on my unit circle, these values in the rectangles represent the tangent values. And the undefined tangent values happen at pi over 2 and 3 pi over 2. So this statement would be false. Okay, because this statement says undefined at 0 and pi, when actually tangent is undefined at pi over 2 and 3 pi over 2. Statement B says both tangent and secant have negative values in quadrant 2. Okay, quadrant 2, we're looking for negative values for tangent and secant. So let's jump on over to quadrant 2. Quadrant 2 is right here. Well, let's look at our tangent values first. Again, these ones in the rectangles are our tangent values. I can see that they're negative. And then we're also asked about the secant values. Well, what we know about secant is that secant is the reciprocal of cosine. And reciprocals don't change the sign of a value. So if the cosine values are negative, then the secant values will also be negative. So since these cosine values in quadrant 2 are negative, so too will be the secant values. So this is going to be true. We'll go ahead and select this answer. Statement C, sine, cosine, and tangent are all negative in quadrant 3. Well, let's look at quadrant theory here in red. Sine values are definitely negative, or sorry, cosine values, the x values are negative. The sine values are also negative, the y values. But however, if you look at the tangent values here on our rectangles, they're all positive. That's because tangent is sine divided by cosine, and negative divided by negative would end up giving you a positive. So this statement is false. And it's all due to tangent right here. Tangent should be positive in quadrant 3. All right, looking at statement D, cosecant of 2 pi over 3 equals 2 root 3 over 3. Well, one thing we know about cosecant is that it's the reciprocal of sine. So all we need to do is find the sine of 2 pi over 3 and then take its reciprocal. So let's look at 2 pi over 3, which is right here on the unit circle. The sine of 2 pi over 3 is square root of 3 over 2. So if we take its reciprocal, the reciprocal of square root of 3 over 2 is 2 over square root of 3. So we want 2 over square root of 3. Well, we know in this class that we don't like square roots in the denominator, so let's go ahead and rationalize the denominator by multiplying top and bottom by square root of 3. This would give us 2 root 3 over 3, which is true. Let's go ahead and select that answer choice. And the last answer choice we want to look at is secant of 4 pi over 3 equals negative 2. We know secant is the reciprocal of cosine, so let's go find the cosine of 4 pi over 3. Well, 4 pi over 3, right here. The cosine value is negative 1/2, so we want to take the reciprocal of negative 1/2, which is negative 2 over 1. Well, negative 2 over 1, that's just negative 2. That checks out. This is also a true statement. Moving on to problem number 5, we want to find the exact value of the cosine of the inverse tangent of 1. With these trig compositions, we know that we want to start on the inside. So we want to start with the inverse tangent of 1. Well, let's remind ourselves of our domain restrictions. When working with inverse tangent, we want to be restricted to negative pi over 2 to positive pi over 2. And we are trying to find, from negative pi over 2 to positive pi over 2, which angle has a tangent value of positive 1. Remember, tangents in our rectangle, tangent of positive 1 is happening at pi over 4. So tangent, inverse tangent rather, of 1 is going to be equal to pi over 4. Now that we've taken care of that part, we just need to evaluate the cosine of pi over 4. Well, looking at our unit circle here, pi over 4, the cosine value, the x value is square root of 2 over 2, so we get square root of 2 over 2, which is answer choice A. In problem number 5, we want to find the exact value of the inverse sine of cosine of 5 pi over 6. Once again, with these trig compositions, let's start on the inside. So we want to evaluate the cosine of 5 pi over 6 first. We don't need to worry about restricted domains for this because we're working with cosine, not inverse cosine. So let's go over to our unit circle, evaluate cosine of 5 pi over 6. 5 pi over 6 is right here. And the cosine value is negative square root of 3 over 2. Okay, so we've taken care of the inside. This is negative square root of 3 over 2. So what we're trying to do now is evaluate the inverse sine of negative square root of 3 over 2. Now, we're trying to work with an inverse sine, so we need to be aware of inverse sine's restricted domain. So for sine and tangent, again, our restricted domain is negative pi over 2 to positive pi over 2. So within the first and fourth quadrants, we are trying to find which angle has a sine value of negative square root of 3 over 2. Well, if I'm looking here in quadrant 4, sine value, the y values, there's a negative square root of 3 over 2 for a y value, and that happens at 5 pi over 3. But 5 pi over 3 is not between negative pi over 2 and positive pi over 2. So now you have to think back to what we did with negative angles. Remember that we said 11 pi over 6. Well, if you started at 0 and rotated clockwise, negative pi over 6 is actually the same. 11 pi over 6 is the same as negative pi over 6. 7 pi over 4 is the same as negative pi over 4. And 5 pi over 3 is the same as negative pi over 3. And this negative pi over 3 is in that restricted domain of negative pi over 2 to pi over 2. So the answer here is negative pi over 3. For problem 7, we want to evaluate the inverse cosine of negative 1/2. Well, let's remind ourselves that cosine, when we're dealing with inverses, cosine is restricted from 0 to pi, or quadrants 1 and 2. So in quadrants 1 and 2, we want to find the angle that has a cosine value of negative 1/2. Well, if you look right here at 2 pi over 3, there's our cosine value, or x value, of negative 1/2. So again, that is at 2 pi over 3. Which is answer choice A. All right, number 8. Given that tangent of theta equals negative 7 over 6, and theta is in between 3 pi over 2 and 2 pi, find the exact value for cosecant of theta. A couple things to notice real quick right off the bat. If theta is between 3 pi over 2 and 2 pi, that means that theta is in quadrant 4. I know this because if I look at my angles here, if I look at my unit circle, 3 pi over 2, 2 pi, everything in between is the entire quadrant 4. So what we want to do is we want to replicate quadrant 4. Now notice on your unit circle reference guide that I've given you, that here on the bottom right, I show you exactly what the triangle should look like depending on the quadrant that you set it up in. We are setting up our triangle in quadrant 4, so this is where our triangle should look like. So let's go ahead and do that. Quadrant 4 lies on the negative side of the x-axis and the positive side of the positive side of the x-axis, the negative side of the y-axis. So positive x, negative y. We have our triangle coming out like this. Here's our 90-degree angle. Here's our angle theta. Now, since we know that tangent of an angle is the opposite leg divided by the adjacent leg, what this tells us is that since theta is right here, the opposite leg should be a 7, and the adjacent leg should be a 6. But now we need to worry about the signs. You know, one of the important parts about replicating the quadrants is to know what to make positive and what to make negative. So notice that since we are on the positive side of the x-axis, this leg right here will be positive. Since we are on the negative side of the y-axis, this leg will need to be negative. So this is a negative 7. Now, we need to go ahead and find the hypotenuse, because when we calculate cosecant of theta, we're going to need the hypotenuse to do that. So let's use Pythagorean's theorem. The leg squared, so 6 squared plus negative 7 squared equals x squared. 6 squared is 36. Negative 7 squared, so negative 7 times negative 7 is positive 49. We add those together, we get 85. And then we take the square root of both sides. We get that x is equal to the square root of 85. Now, the square root of 85 cannot be reduced any further, so our hypotenuse is square root of 85. Okay? And note that the hypotenuse will always be positive in these triangles. So now that we have our triangle fully set up here, we want to go ahead and try to calculate the cosecant of theta, which is what we've been trying to do this whole time. So the cosecant of theta, well, we know cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So the reciprocal of that would be hypotenuse over opposite. Well, our hypotenuse is square root of 85. We just found that. And our opposite, well, opposite of theta is -7. So we have square root of 85 over -7. This is just, we take the negative from the bottom, move it to the outside, negative root 85 over 7, which is answer choice B. All right, moving on to problem 9. Solve 4 equals 6 plus 4 cosine of x, where x is between 0 and 2 pi. Okay, so our goal here is to get the cosine by itself. Let me rewrite the problem real quick. Let's go ahead and subtract 6 from both sides. This would give us -2 equals 4 cosine of x. We can now divide both sides by 4. This would give us -1/2 equals cosine of x. So our job is to find all the angles x, where if I take the cosine of those angles, I would get -1/2, and we're restricting ourselves between 0 and 2 pi. So let's look for all the x values, the cosine values, that have -1/2. Well, here's one at 2 pi over 3, and here's one at 4 pi over 3. So our answer choice would be A. So x is the set, 2 pi over 3, and 4 pi over 3. I think I said A was the answer choice. That's obviously not true. That'd be D. All right. Now, we can check this graphically with Desmos. Notice that if you want to use Desmos, one side of your equation needs to be 0. So if I would have subtracted 4 from both sides, then I would have gotten, so I'm going to, little star here. If I would have subtracted 4 from both sides, I would have had 0 equals 2 plus 4 cosine of x. And if I go and check this with Desmos, so plug in 2 plus 4 cosine of x, notice that between 0 and 2 pi, any point where the curve crosses through the x-axis would be a solution. We have a solution at 2 pi over 3, and we have a solution at 4 pi over 3, which is what we saw when we did the work by hand. So again, for Desmos, you need to make sure one side of your equation is equal to 0, then you look to see where the curve passes through the x-axis. We'll do the same thing here. We'll solve number 10 algebraically, or by hand, and then we'll check graphically. So we have 2 cosine squared of x minus cosine of x equals 0. First thing I notice is that both terms on the left contain a cosine. So I'm going to go ahead and factor out the cosine of x. If I factor out cosine of x from 2 cosine squared of x, I'm just left with 2 cosine of x. If I factor out cosine of x from negative cosine of x, I'm left with -1. Here, the zero product property will kick in. We know that we have cosine of x times this entire piece, 2 cosine of x minus 1. So zero product property tells me I can take the factors and individually set them equal to 0. So one factor is cosine of x. The other factor is 2 cosine of x minus 1. Set these equal to 0, and essentially we have 2 separate problems that we need to solve, and we'll collect their answers. So the first part, we need to find where is the cosine of x equal to 0? Well, the cosine of x is equal to 0 at pi over 2 and at 3 pi over 2. For the right side, let's go ahead and add 1 to both sides, so we get 2 cosine of x equals 1. We would then divide both sides by 2, getting cosine of x equals 1/2. And now we want to find, between 0 and 2 pi, what are all the angles where the cosine of that angle is 1/2. So looking at our unit circle, pi over 3 has a cosine value of 1/2, and 5 pi over 3 has a cosine value of 1/2. And if we collect all those answers together, pi over 2, 3 pi over 2, pi over 3, 5 pi over 3, that would be answer choice C. Now let's check that again with Desmos. Notice that this one is really easy to check because we've already got one side equal to 0. So if I just take 2 cosine squared of x minus cosine of x and plug it into Desmos, we can find all the locations that the curve passes through the x-axis between 0 and 2 pi. Here's one at pi over 3, pi over 2, 3 pi over 2, and 5 pi over 3. And notice again that we're stopping at 2 pi because we're restricted in our domain here. All right, moving on to problem number 11. Select all statements below that are true regarding the graph of the cosine function. It's bolded, so the parent function, or we know that this function is a cosine function. So statement A says the amplitude is 4. Well, we can find the amplitude by taking a look at the midline. I can see here that the midline, let me make that a little bit better. The midline is here at -1. I know that because the distance from the midline to the top is equal to the distance from the midline to the bottom. So that distance that we were just talking about from the midline to a maximum or the midline to a minimum was 4. So the amplitude is in fact 4. Statement B says that the period is pi. Well, we can tell period by looking from peak to peak when we're talking about sine or cosine functions. So if I go from peak to peak, for example, right here, and look at that horizontal length, that would tell me the period. I'm going to go ahead and highlight that little section there. So that's one complete cycle, peak to peak. And notice that, our cycle starts at 0, but this location where it ends is not pi. So the period could not be pi. So this would be false. Statement C says the graph has undergone a phase shift to the right by pi over 4 when compared to the parent function of cosine. Well, let's think about the parent function of cosine. We know that the parent function of cosine has a maximum at 0, 1. And notice that we have a maximum at 0, 3, meaning that our graph did not undergo any kind of phase shift to the left or right. So this would have to be a false statement as well. And then statement D says the midline is at y equals -1. We've already drawn in that midline. We can confirm that is correct. Midline is at y equals -1, so this would be true. Number 12, what is the period of the graph provided? So again, we have either some kind of sine or cosine curve. And since we are dealing with period, we can look from peak to peak, or we can look at one complete cycle. I'm going to look at from peak to peak. So here's one peak. Here's another peak over here. That would be this entire length. So the horizontal length from peak to peak would be our period. Notice this starts at 2 pi and ends at 10 pi. So the distance from 2 pi to 10 pi would be 8 pi. Okay, next looking at number 13 here. It says, what is the equation of the graph provided? Now, let's think about some answer choices that we can eliminate right off the bat. Two of our answer choices are tangent curves. Two of our answer choices are cotangent curves. Let's think about what tangent looks like real quick. When you think about tangent, tangent looks like that. Cotangent looks like that. We definitely have cotangent curves. So let's go ahead and eliminate A and D. So if you're looking at your remaining answer choices, they both have vertical shifts of down 1. So that is something that we know. Vertical shift, down 1. But that doesn't really help us because, again, both of these answer choices have vertical shifts down 1. So we need to take a look at the B term. The B term for answer choice B is 1/2. The B term for answer choice 2, or for answer choice C, is 2. So remember that the B term helps determine the period. And for both tangent and cotangent, the period is pi divided by B. So if I take this one, for example, the period, the period for this, so we're looking at answer choice B, period would be pi divided by 1/2. which is pi times 2, which is 2 pi. Well, if we look at our period over here on the graph, again, we're just looking for the length of one complete cycle. One complete cycle here would be from 0 to pi over 2. So the period should be pi over 2, meaning that this period is incorrect. And our answer choice would have to be C. And just real quick, let's look and see why answer choice C would have the correct period. So again, the period would be pi divided by the b term. In this case, the b term is 2. And the period is pi over 2, which is exactly what we see from the graph. We can see the period of the graph, pi over 2. That's the horizontal length of one complete cycle. And you can also tell the period from a tangent or cotangent graph by looking at the horizontal distance from asymptote to asymptote. All right, next, statement 14. Which statement is false regarding the equation y equals 4 tangent of 2x minus 2? Well, statement A says there is no amplitude. That's true. Tangent and cotangent, they don't have amplitudes. Amplitude implies that there's a maximum or a minimum. There is no max or minimums with tangent functions. So this is true. However, take note, we're looking for the false statement. Statement B says the period of the function is pi. Well, let's test that real quick. We know for tangent that period t is pi divided by b. And we know here that the b term is 2. So pi divided by 2, that's just pi over 2. This is going to be a false statement. Now let's look at C and D. Even though we know B is the answer here because that's the false statement, let's see why C and D are true. C says the function has undergone a vertical shift of down 2 when compared to the parent function of tangent. That would be true because we see the minus 2 out here. So vertical shift of down 2 is true. And then D says there will be an asymptote at every odd multiple of pi over 4. Well, let's see why this would be true, and it's best to see this by graphing it. So let's use Desmos to graph 4 tangent of 2x minus 2. So 4 tangent 2x minus 2. And if let's get rid of these here and kind of zoom out a little bit, zoom back in, we can see that the asymptotes would be here one asymptote would be between 0 and pi over 2, which is at pi over 4. Then we would have another between pi over 2 and pi, that'd be 3 pi over 4. We'd have another between pi and 3 pi over 2, that would be 5 pi over 4. And all these asymptotes are indeed happening at every odd multiple of pi over 4. So that would also be true. All right, on to our last problem for our review here. Select the correct graph below for y equals -1 plus 3 cosecant of x minus pi over 4. Okay, so there are a couple options that we have here. Number one, we can take a look at the parent function for cosecant and try to select the correct answer by observing some transformations. We can also do ourselves a favor and try to eliminate some obviously wrong answer choices based off of some easy to pick out characteristics. For example, this first part here, this -1, because it's on the outside, it doesn't matter that it's up front, it could have been back here also, but this -1 indicates that there has been a vertical shift of down 1. Now cosecant, when you think about the parent function of cosecant, it has that kind of empty space between -1 and +1. And if you look at graph A, you have more empty space up here above the x-axis than you do below the x-axis, indicating that this graph has been shifted up 1. So we want to shift down 1, so we know this would be incorrect. We could say make a similar argument for answer choice C. Answer choice C, we have an equal amount of space above the x-axis as we do below the x-axis, meaning that there has not been a vertical shift at all. But we want to see a vertical shift of down 1. So if you're looking at answer choices B and D, we'll notice they have both been shifted down by 1. We can see that here. So let's look for some other easy to identify pieces here. One thing I'm going to take a look at is the minus pi over 4. Minus pi over 4 inside the parentheses means that this has been shifted to the right by pi over 4. Well, let's think about the parent function of cosecant of x. So let's go ahead and pull that up. So cosecant of x. Notice that the cosecant of x has asymptotes at 0 and pi, and has a midpoint for one of those little sections right there at pi over 2. So if we pull up our graph here, well, if I were to look right here at answer choice D, this is where that little point would have been, and we can see that it's been moved to the right by pi over 4. So I'm definitely thinking D is going to be my answer choice. We can verify that by looking at a graph of it in Desmos. So let's go ahead and graph -1 plus 3 cosecant of x minus pi over 4. Let's verify some points here. We can definitely see here is that pi over 2 right there. We can see this point that's been shifted to the right by pi over 4. And this is definitely looking like the correct graph. So we would go ahead and select answer choice D.